I guess I'll go first. So this is a thing I was looking at the other day. I don't have an answer yet. I have a few things that I know it's not. So I'm just going to share my screen, I guess. So this came from me looking at the error budgets for a stage group. And I noticed that, so this is the distribution of requests, HTTP requests in our logs into 1 second buckets by the duration they spend. Our logs say they spend in the shared state Redis. I've excluded ones that take less than a second from here because, I mean, the vast majority of requests should take less than a second in any Redis. Like, it's Redis. Like, this shouldn't be a thing. But what I did notice as well was that there's this big spike at 5, which is suspicious. And there's also, you can see there's basically nothing at 11, 12, 13, 14. But there is something at 10 and 15. And possibly at 20 as well, though it's hard to see. So I've just taken the filter off here, and you'll see that under 1 dominates this. But this is odd, right? Because like a Redis command is not going to take 5 seconds, certainly not an appreciable number of Redis commands, certainly not 44,000 in a day, because if they did, our slow log would be full of that, and Redis would be failing.
This makes me wonder if they're, sorry, go ahead.
So I know a few things it's not. I also noticed this happens in our Sidekick logs.
That's normal though.
For the shared state Redis for Sidekick?
Oh no, I thought you were switching to the Redis Sidekick.
Oh no, sorry. Yeah, so so this was, the top one was from the Rails logs. Oh yeah, so here's the Rails logs by, if you include under 1 second, and this, obviously that's unreadable. Okay, just give me a second.
So this makes me wonder if maybe we are running blocking commands, not necessarily brpop, but any blocking command on that would have an implicit timeout and a reason to wait.
Yes. Sorry.
Oh, you heard that?
I heard the part about timeout. So
yes.
Yeah.
I was wondering if there was like a block, maybe in persistent Redis, we are still running blocking commands that would have a timeout, not necessarily brpop, but any blocking command.
Yeah.
What time span is this survey covering?
That was a day, but it applies to any day. So like I created this issue in July, and the chart basically looks the same today.
So we don't explicitly remove those commands from that Redis duration, then the blocking ones.
Are you talking about in the instrumentation where we remove some commands? Let me check. Oops, that was the wrong one. This one.
Because
so they are excluded from AppDex, but not from.
Right.
Are they excluded from logs? I can't even tell with how this works. Let me see. No, I think this is what adds them to metrics and to logs. So these will be excluded from both AppDex and logs. But I can double check on that. I'm just going to rule out one more thing. I was speaking to Jakob about this yesterday. He was off today. He was wondering if it was at a certain point in the life cycle of the process, like either the first or the last request, like especially the first, if it's some kind of timeout related thing, maybe it's a client timeout, but it's not. So here's when this happened for 2 different Kubernetes pods. And you can see that there are requests before ticking along normal, and then there's a spike, and then it goes back to normal. Also, it doesn't happen for any other Redis instance, which points towards maybe a command, like I think Matt was just saying, because it doesn't happen on the cache instance, the queues instance, or the trace chunks instance.
Can we get a frequency by time of day?
That's a good idea. Yeah, let me.
I'm mostly asking because I'd like to catch some of these in the act, and if I can get an idea of how often they occur and at what density, then I'll know how long to run instrumentation for.
Yeah. So one idea I had for this was performance bar. We have a stack trace for requests to Redis. So I was like, if I can grab one of these, because these happen for like me and for you probably. but they mostly happen on async requests, so you don't notice them. If I can grab one of these for somebody who's got the performance bar enabled, I can grab that request ID and put it in the performance bar to get it. So I got the performance bar data, but unfortunately, the performance bar, because it's, I think because it's happens in the Rails controller, it won't catch things that happen outside of the controller lifecycle. So if we see here, where are we? So first of all, we can see the duration is 5 seconds. So it's not, it's unlikely to be a measurement error, which is another thing I was wondering, because if it was a measurement error, the total duration wouldn't be affected. And also the workhorse duration says this took over 5 seconds. So it seems like this was actually a very slow request. But we can see that total Redis calls were 19, of which 7 are on the shared state. And here I've got total as 6, of which 0 are on the shared state. So I'm clearly missing a bunch of stuff in the performance bar, which is a separate issue. Another idea I had to get a stack trace, sorry, I'll set up this time of day chart. What do we want? Let's just say this specifically. So let's say this is between 5 and 5.1. Oh, this chart is the wrong way around, really, isn't it? Is there an easy way to change chart type, or am I just gonna have to do?
Not that I've seen, unfortunately.
No, because that would be too easy.
Yeah. And this also bugs me because like these are valid, but like basically I always
don't get me started, Sean.
This. Right, so buckets by date histogram, JSON.time, y-axis can be count for the last day. Or actually we could probably, yeah, let's just do for that. Well, I guess that does help you, Matt, in that you can do it at literally any time.
Yes, that's great. Zoom into any one of those. I guess let's look at the last couple of hours. And yep. Yes, I want to see if it's bursty on a shorter time scale.
Yeah.
Change the granularity. What's the granularity now? I know it's set to auto by default.
Yeah,
30 seconds.
Is 30 seconds. So do you want it to be?
Oh, great.
To be lower
but
or
make
higher?
it an hour, because it does seem to be like something around maybe.
Do you mean a minute?
Oh, sorry, no. Make the time span.
The time span.
Oh, sorry, got you.
Yeah.
Wait, what? Oh, that's the start. Whoops. So this is by minute.
Spot. Yeah, I mean, there's definitely a ping there.
12:22, 12:04.
Yeah.
Okay, so that periodicity is
12:40.
Definitely
that's
come in
every 18 minutes. So that's -8 is 40, -8 is 22, -8 is 04.
Well, that's kind of.
I mean,
interesting.
It's blobby, right?
Approximately every 18 minutes.
Okay, awesome. Send me a link to this query, and I'll.
Which endpoints is it spread around?
I'll try.
Oh, good question, Andrew. So I discovered this because it happens a lot on internal allowed, but this is basically a chart of which endpoints hit the most often.
Yeah.
Like, this isn't really narrowing it down.
Wow.
I'll just pop that link there for now, Matt.
The other thing we can try and do, which one was it? The shared state, you said. And it doesn't happen on the others. The one thing you could look at is what calls are being made on shared state that you don't get on the other two.
Yes.
I mean, I suspect there's quite a lot because, I suspect there's quite a lot because it's so much more generic than, the one's just a cache.
Yeah, I mean, cache is mostly going to be gets and sets, right?
Yeah.
This is a wacky idea I had. So I've got a slightly improved version of this locally. But yeah, basically, if we just say, if this duration is over 5 in our logging block, track but don't raise an exception, so we put it in Sentry, so we'll get the backtrace via Sentry, and then maybe we can see where in our stack this is coming from, because the other thing with 5 seconds is we are measuring, I don't think it's this, but the measurement includes this. You can pass a block of Ruby code to be run with some commands. So it will include the time it takes to run that block. So
that's a big clue there.
But these are the commands that can take a block. So not every command can take a block. And it sounds more like a timeout than Ruby code taking exactly 5 seconds every time to me.
Yeah, that boundary you showed of 5.0 to 5.1, that's very suspicious of timeout behavior. I think I can identify which specific Redis commands are involved, but it'll take a little post-processing. I'll probably also be able to find out which hosts are sending those requests, but not necessarily which application code path. At least with what I'm thinking of doing right now.
Okay, so maybe we should take this as a two-pronged thing then. Like I can't think of a better idea than this to find on the application side.
Sure,
but
yeah,
like
I think that's reasonable.
Maybe this is fine. And
those Z scans at the bottom of that list of things that take a block, all the scans, in fact, do those blocks get called multiple times? I'm just trying to remember how they work in the case of those scan. They called for every single item, not the. So those could take 5 seconds if it's measuring the entire scan, right?
Possibly. I just feel like it's unlikely that it would take pretty much exactly 5 seconds every time.
Yeah.
I mean, yeah, I don't know. I guess if we get the commands, that will narrow it down a lot already, because if it's not one of these, then it's clearly not a Ruby side issue.
Yeah. It would probably be worthwhile having the measurement excluding like the block if we could.
Yes, it would.
It's not really helpful having that in there.
I don't know why.
Let me speak here for a moment.
Especially for the Z scans, because those, you could have a process that's kind of doing something inside. I mean, I hope people aren't using scans a lot.
Well, I mean, you can literally do like sleep in the block and then it'll take 5 seconds. That was how I tested this. So yeah, not super helpful to conflate the two things like that. So yeah, I just wanted to share this as like something I've been looking at, but I don't really know what's going on.
That you found this and you're digging into this. This is like pure scalability awesomeness.
But the reason I found this was because we were looking. Sorry, I might just need to go and deal with something.
I mean, my gut is that it's definitely on the client somewhere, and but it would be good to understand that.
Yes, agreed. This is why I want to do instrumentation to catch a few examples of this occurring.
Yeah.
Hey, sorry.
Are you going to use RB Spy or something like that, Matt? Is that what you're thinking? Out of interest.
No, I was thinking more primitive than that, but I've got a couple of rough ideas, and I want to check that they're viable before I actually execute them.
So sorry, what I was going to say was the reason I found this in the first place was because of the error budgets work. So I was looking at the error budgets for source code, who have a lot of these ones at the top, because source code is one of the groups that owns most of the requests that we make, because they own Git access.
It's about 33%.
Right, there we go. And I was like, by proportion, like these endpoints aren't most of their failing Apdex requests, right? Because there are so many of these requests that actually proportionally, the number of requests on API internal allowed that take over a second is quite low. But by overall count, because there are so many requests to API version allowed, this actually does make quite a big difference to their error budget. And I was going to create an issue for them, but then I realized it happens on everybody's endpoints, and it doesn't seem to be related to like what any particular stage group is doing. So this did come out of the work on error budgets, and I think this probably would make a dent in our overall Apdex score if we could stop it happening. Because
some of the alerts I got last week ended up resolving down to internal allowed being running for multiple seconds.
Okay.
So yeah, definitely this would help.
Yeah. So Sorry,
And you do notice it sometimes when you push like things just sitting there, and it's probably that, right? So it's not like
well, it's also possibly other
victimless
stuff, but yeah.
Yeah, but often you see that, and it's kind of inexplicable because it should always be fast, right?
It should always be
It's one of the ones we
approximately
should
the same
really have
speed.
the most.
Yeah.
Pardon?
Should always be approximately the same speed for
Yeah.
sure. Yeah. And the thing is, I've noticed when I'm looking at these, like, because so many requests to the web and API servers are either API requests from CI, like, you know, that's what a lot of API internal allowed calls are, is from CI, or from Ajax requests. Like the one I showed earlier that was my request was a request for the merge request widget, like, you know, polling. You probably won't notice it that much because like it'll just be in the background somewhere, but it's still happening. So yeah. I want to know, basically. I want to know what's going on here.
I'm most intrigued by the 18-minute cycle there.
Yeah. So yeah, Matt, I've just pinged you on that issue. I was wanting to chat to you later anyway about the Sidekick stuff you were talking about yesterday. So maybe we should just chat about both later, if that works for you, or yeah, we can see. But yeah, that would be good to get some help and try and unravel this.
Yeah, definitely. So yeah, because we've got this periodicity, I think what I'm going to try to do as a first cut is, sorry, Andrew, I said earlier that I had two ideas, but I neglected to articulate what they were. One is packet capture during one of these periods, and because we have dense period, I should screen share just to show. This is Sean's query. Oops, stop that. I just pasted a screenshot in the issue, but this shows even more clearly the periodicity. All I did was switch this to an area display from a line chart to a bar chart. So I'm going to time it. So first idea is packet capture, do post processing analysis to pull out the calls that have this duration, and that will identify the command, its arguments, and the client IP, which, you know, in many cases I think will be a Kubernetes pod, so that won't be especially useful. But identifying the nature of the command is probably going to be more useful for analytical purposes. Since we do have these dense periods, I think I could probably get away with doing like a 30-second capture if I time it right. So I think that's probably the better approach because it will give more data and it doesn't burn Redis's CPU. It will burn a separate CPU. The second idea I had.
Sorry, yeah. Matt, where's the packet capture happening here? Is it happening on the Redis server? Okay. Yeah. The only thing I'm wondering here is if it's timeout, if it's client-side issue, yes, we might not see anything there. But I guess that will tell us. That will falsify
exactly
that. Yeah,
that's exactly the absence of data on the Redis server side tell us that. Yeah, so I would come back here to confirm that the selected time span did have client-side measurements that met that time, that duration, and we'll see how they match up. The other idea I had, which I don't think I'll do because I think we'll get more information and less impact from the PCAP instrumentation, is because we, thank goodness, have debug symbols on the Redis server. It's possible to instrument shared code paths like process command, for example. So we could measure the distribution of durations for completing process command, and that would tell us something about whether or not this was, for example, that would be a reasonably cheap and quick way to identify if this was a blocking command or not. I need to instrument additional data, additional function calls to determine which specific command, and if it is a blocking command, there's a separate code path I need to instrument. So that would be a little bit more hunting, and it would still not give us information about, like, for example, the arguments to the command. So that's and it would consume some CPU time within the Redis main thread, which is undesirable because that's its bounding capacity. So that's why I'm leaning towards the PCAP analysis. It'll be more informative and it will spend someone else's CPU, not Redis's CPU.
That will not pick up if it's a block or something in the Ruby side. The other thing I was wondering is, have we tried to look at the staging Jaeger? Because it might be.
I haven't even looked if this happens in staging at all.
Because
I should mention that blocking commands do actually have a client response that Redis will send. So, like if it's timing out from a BR pop timeout.
Sorry, I meant a client. I meant a block on the client. You know, the yield blocks rather than a blocking command.
Yes, that's what. I think that's what Sean was referring to earlier. So if we have a spike in the Kibana log events, but don't have a corresponding spike for the same time span in the PCAP, that would infer from that it was client side. Does that hold water?
What was it going to say? Yeah, I mean, I like looking at the spread, right? It's probably something in access. It's got to be like a permissions check kind of thing, I imagine.
Yeah.
And I mean, it could be something else, but like just the
database
way it's so
load balancing is a thing that happens on every page.
Yeah, that's also a good option. But neither of those I can imagine have any blocking calls. I mean, they might do. I could be surprised about anything, but like I wouldn't imagine. But maybe they do.
And why this 18-minute periodicity?
Yeah, totally.
Very odd. I can't wait to find out what this is.
I had a look on staging. This happened once in the last day, so I don't know if that's a real
and the chances of that coinciding with a trace are very low.
And I don't know what the periodicity on that is because it's happened once in the day. So I think it's worth looking into this because I mean actually the other thing I should have mentioned was, so I said I was looking into this because of the source code group's error budgets. The source code group are also looking into their error budgets, which is good. That's what we want, right, Rachel? Teams looking at their error budget spend. And they asked me, like, have you noticed that like this takes 5 seconds a lot of the time? So they're also finding this. So it would be good to answer that for them as well, if not just for ourselves. Anything else on that one?
There is more emphasis coming on from the error budget side of things. So the more things that we know ahead of them is good. Like it's all helpful to be able to I don't know, just to give more confidence around the error budget process and mechanisms if we're able to answer these kind of questions. So I'm glad that this is going to get looked at.
This is awesome. This is exactly why we have these things, and this is how we
is there anything more on that topic, or can I ask another question about error budgets? Cool. I'm looking for a reminder about not owned in the error budgets, and I was wondering, apart from GraphQL, what other things need to happen to attribute more of that not owned group?
Reactive caching.
We talked about this in the last demo, Andrew. So I've got an MR to make the reactive caching take the feature category from its caller, which will inherit as well. So sometimes you have a reactive caching worker called by a reactive caching worker. And if it will take that from the first caller. So basically, I think the logic's getting, I don't want to make the logic too much more complicated than it is now, because this already caused some confusion for Matt yesterday. It's actually related to what you were asking me about yesterday, Matt. So with our context propagation particularly from a web request to a background job, a sidekick job, we want to inherit every single field, like user, root namespace, project, except some cases in a background job, we want to clear all of that because we're operating across multiple contexts. And the feature category, we normally want the feature category of the job, not the feature category of the caller. Because the feature category of the job is generally more specific. So even if say a merge job is called from a CI page, the merge job still owned by the team that owns the merge job. It's not owned by the CI team just because they need to make a page that triggers that worker. The exception being not owned workers, because for those, not owned is essentially like, we can think of that as a null value. So for there, we do want to get it from the caller because that at least helps us attribute.
And then it's starting to get quite complicated though. And then people sort of start squirming a bit and they're like,
yes,
well,
so I don't want to make it, this is the most complicated I want to make it. So I've kind of paused that MR for now because it's also going to cause more confusion as we do the rest of the catch-all rollout, because it already something related already gave Matt a fair question yesterday. But I think inheriting, if it's not owned, if we had null instead of not owned there, I think that would make perfect sense. It's that there is a concrete value that we're treating as like a null that is the weird bit. But
so if we did more work to fix the attribution on the Rails controllers, or on the Grape and Rails controllers, right? And with GraphQL, we have an approach for that. Then we wouldn't need the kind of conditional. We could just say it comes from the oh wait, sorry.
No, we still need the conditional, but
you're saying the opposite.
But we basically never need to care about not owned sidekick workers, because they will, if they are not owned, they'll get their feature category from whatever calls them. So we don't have to go. We only have to go through the not owned controllers and API endpoints, not the not owned jobs. But I agree, it is a little bit confusing to explain. So I'm not saying that's the most elegant option. I think that's just the option that gets us pragmatically the most of what we want with the.
I mean, the one thing I've really noticed is now that it's starting to bite, the error budgets.
The GraphQL.
No, just in general, error budgets and people and pushback on fixing technical debt. People are becoming a lot more interested in the accounting of it. And often it's in big meetings with lots of very busy people, and I'm realizing the importance of keeping it simple, but this might be the only way. But I am also seeing like people are like, no, but this number doesn't make sense. Like, explain it to me. And they sort of give you 10 seconds to explain it. And so it is kind of like, and those are the decision makers, right? So you've got to have them bought in. So just something I've been noticing recently, especially in last week's,
I think the other option there is like
engineering allocation.
We kind of talked about this a bit before, but the other option is with these not owned workers, we could go to the other extreme and just make like a not owned, like a reactive caching worker for each feature category that uses reactive caching, and like have each one use the correct one. I mean, that's a lot of code duplication.
It's for
metrics point of view. So
I think it's reasonable, but
we'll see how it goes. Like I said, I paused it for now because I think it could cause confusion with the next stages of the catch-all sidekick rollout, because we're doing that by feature category. So if we create a metrics query that uses feature category and not owns in the mix, we don't want those to be conflated just right now. Like in a week's time, it'll probably be fine. But so Rachel, that answers a small part of your question, but I don't think it answers the rest of it.
Well, it's helpful because it already tells me what the two main things are that are actively in progress to sort it out, because that was one of the questions that's coming up, as Andrew says, with the error budgets getting more attention. So what I'm doing at the moment is trying to find all the pieces that people may be concerned about regarding error budgets and say, well, either this is what we're doing or this is what we're going to do, or no, we hadn't thought about that yet. But to list out those things so that people have some idea of where error budgets are going to go next. So that this is helpful for me because I can just put that in the list. Is there anything else that anyone would like to demo or talk about today?
Yes, but I need just a moment before I'm ready to talk. I want to go back to our first topic. I don't know why I'm having an awful time putting a comment on our on the issue. I think this is probably a client side thing. Okay, I'll push this as is for now, and I'll put more details later. Okay, screen share. This is what we were looking at earlier. Is this sharing properly? Can you see?
Yep, perfect.
Okay, great. So we've seen this together. We just did this. These are the 5.0 to 5.1 duration periodic spikes. These are the RDB backups running on Redis. The timing and count matches perfectly.
Okay.
RDB backups on Redis, and this is
Good
the overall
spot.
CPU usage,
Yeah.
which is not super great to see, but this is So this is it's easier to see on this graph that's showing per CPU core usage. You can see that these spikes are attributable to exactly one core, which means exactly one process, which means this is very likely to be the RDB backup process. RDB backups effectively run by forking the main the Redis server process, so that it begins life with an identical copy of the virtual memory for the main Redis process as of a point in time, and Linux will implement copy on write for all of those memory pages. So as the main process mutates those pages, new pages get allocated, which for the forked child process that's actually trying to write the backup file out. And that is why this graph shows spikes in page usage. So if I suppress this, we get to see the growth is primarily coming. The growth in memory usage is primarily coming from anonymous pages, which is because of the copy on write for Redis's actual data store, and also in cache because the whole point of this forked process is to write out files to disk, which of course go through the file system cache.
So do we not do RDB backups on the other instances, or?
We definitely don't do them on Redis cache.
Because that's what the cache means.
Yes, I would have expected us to see to do those on Redis Sidekick, but I'll go verify that. It may be that I don't know. I mean, right now
Sidekick's got quite a different load though, so
yes,
it's not likely. It's possible that it's just not affecting that.
Because that means Sidekick's memory usage is, I'm pretty sure, is much lower, right? It's the CPU usage that's the problem on Redis Sidekick.
Yeah.
Matt, there's a graph, if you go to the Redis dashboard, for the amount of memory used during the copy on write, if you go to Redis main and then go, or however you want to get there, there's the amount of memory that was used during the copy and write by the fact that it was mutating in the main Redis thread, right? And it'd be interesting to see, because if you only see a problem with that on the shared, then it's might be something to do with. It's still very strange.
So
yeah,
why
seconds
where you're
still
looking.
Yeah. If you down, it'll be down, not in the indicator detail, somewhere down here. I mean it's definitely metric, but I don't know if we plot it. Doesn't look like it. There those spikes are again. Or is that no? Sorry, is it
key expire? I don't have the same time span set here. Let me
okay. It's
here. I wanted to match what Sean had set for the Kibana graph.
Yeah, there's a like a metric which shows you how much memory you basically use by the copy part of the copy and write, and that I've found in the past is like quite an interesting metric to tell if
that's
RDB snapshot's getting too long and you've got too much change.
That's what we're seeing here. This is a direct measure. Well, this is a direct measure of that.
So
this might be a silly question, but so my understanding was that for Redis persistence, say we have a primary and secondaries, and all queries all commands go to the primary.
Yeah.
So why do we need RDB backups on the primary anyway? Could we not just take those on secondaries?
Perhaps we could. The role can switch without notification.
Right. So you'd have to figure out, am I a primary?
Yeah.
Yeah,
Yeah.
got it.
I don't know that.
I mean, I'm not saying RDB backups should be a problem, just to be clear. I'm just curious.
Right. Yeah. No. Yeah. It's a good question. I think the answer is just that we configure the primary and secondaries the same, because any node could take up that role. Yeah. I'm sorry, Andrew. I'm not finding.
No, it's fine. I found it in Thanos, and it's
okay. Do you want
about. Yeah, I'll put it into. I'll just put into the. No, it's fine. Well, it doesn't really show us anything much, but I'll show you. It might be worth investigating, but I'll share my screen quickly.
So I mean, I don't want to make this sound like it's causal. Currently, it's just correlated, but it's a strong correlation. So I thought it was worth.
Yeah. I think it's a very interesting. One of the things that's kind of weird about it, though, is it doesn't seem to affect all the Redis queries that are, it seems to affect a handful, because obviously there might be 20,000 going through.
Yeah.
And we don't see it in the Redis slow log.
Yeah.
This is going to be very interesting, and I'm really looking forward to figuring out, someone figuring out what it actually was.
Yeah.
Because that is very strange.
Are you wearing a Redis shirt right now?
I am. These shirts are really nice. Get the Redis shirts, because they this is pretty old, but they're just good swag shirts.
They're comfortable. Nice.
Yeah. Sean, like what I was saying, because like what I've seen in the past on, I think when we were still on Azure a long time ago, there was something with the hypervisor and forking Redis processes. I forgot, it's like lost in the mists of time, but it basically, when we forked and did the copy and write, it performed really, really badly, and things basically came to a halt. But if it was something like that, you would see far more requests that would have slowed down, but it's just like a handful, and that's what's really strange.
Yeah. Yes, and it doesn't explain the very tight 5-minute window. Like we're looking at 5.1.
Yeah, that's the part I don't understand. Like if it's a 5-second window, I don't think the volumes look right for all the requests that happened within that 5-second window, if you follow me. Like,
no, it will be much, much higher than that. I mean, we're looking at many thousand per second, right?
Yeah.
So I think I'll proceed as we talked about before with the PCAP instrumentation, and I'll try to get to that today, so we've got something to look at tomorrow.
Yeah, this is I was almost
know if the copy and write stuff is actually relevant. I would expect that to affect things on microsecond or possibly a millisecond time scale for, without any entity to modify the page tables. I would expect the process doing the mutation to have to incur that overhead. So that would be the Redis the Redis main thread, not the process doing RDB backup. Would be my guess, and I would expect that to be on perhaps a microsecond time scale on a per event basis, but those events would happen very often, and so it could cumulatively add up to a lot. Especially early in the process before most of the pages have mutated. I don't see how that would. I cannot imagine a way that would be biased to affect commands that
1%.
For a single
it's
duration.
Very curious.
And then they all come out at 5 seconds, like as Sean says.
Yeah, but they line up so well.
Yes, so it's hard to ignore. I mean, maybe it's nothing, but it's
Because I was
Sean,
assuming
those.
Sorry, go on.
Sorry, those requests, are they coming back with 200 when they come back? Are they successful when they
The ones I looked at, like they're just slow.
Okay. So it's not like they're timed out at 5 seconds.
No. So the other thing that's weird is that, I don't know, I was assuming that they would show up in the Redis slow log, but if it's an issue with like actually processing the command on the Redis side, like before it gets to the process command stage, before it decides which command it is, then maybe that wouldn't be counted in the slow log. I don't know. I feel like we learned more and we understand less now.
Yeah. Before I was kind of a bit skeptical that PCAP would get anything, and now I'm like, the PCAP will tell us what's going on here.
Yeah, that is weird. Also, to be honest, the spike above 1 second is still a bit concerning. You know, like in that first chart I showed, there's like 1 second, 2 seconds, 3 seconds, 4 seconds, and then 5 seconds is longer. The spike above 1 second is still bad.
Yes,
it's just that the one from 5 seconds is so noticeable that.
Yeah, well, if what we learned for the 5 second spike doesn't also explain the 1 second spike, we could repeat methodology.
True.
This is so fascinating. I'm glad you shared this, Sean.
Cool. Well, let's report back next week, I guess, with what we found. Yeah.
Rachel, are you comfortable spending a little time on this?
Yes, as long as a single queue per shard is still going forward as the highest priority thing, I don't mind if the rest of the time's looking at this, because this is, it's interesting to see what's in here and why this is happening. And I think any time that we spend researching interesting things like this gives us more understanding of how else we can tweak Redis in our favor to make it more and more performant. Because, I mean, as we've seen from the latest Tamlin reports, like we're also going to have a problem with the cache one as well. So yeah, any additional understanding we get, I think, is super helpful. But yeah, single queue per shard still needs to be it still needs to get finished.
Sounds good. Sean, I saw you wrote a comment. I rolled out of bed to join this meeting, so I haven't read it yet, but I'll read it right after this.
Yeah, my comment. Yeah, no, I asked you on Slack actually, like, when do you want to pair up? So just let me know on Slack. But if you want to roll back into bed for a bit, that's totally fine, because it's like before 7 where you are. So yeah. Cool. Anything else?
Awesome. Well, thanks so much for joining the call. Looking forward to seeing what we find. This is interesting.
Bye, everyone.
Have a nice day, everyone. Bye.